Hi guys. Hi, I'm Adam. I'm an architect and I'm working at Capgemini. I'm running a group of enthusiasts of GenAI and we are building and designing GenAI agents. Actually, we are kind of lucky because we have bet on this agentic horse over 2 years ago. And now everybody is crazy about agents, there is huge hype. But 2 years ago, we were not even calling them agents, we were calling them, software which is using large language models via API, and it's also using some tools. So yeah, I guess agents is probably a better word to put it. So let me start with a vision, right? So in my job, I always talk with clients because first of all, I need to understand the client problem. Without solving the client problem, we cannot make any business, right? So the vision here would be, client tells me about some problems and I say, oh, for this problem, I have this agent. And for that problem, I have those two agents and they just fix it, right? Of course, we are not there yet, but we are getting there. And in order to achieve this vision, we need to follow certain rules. So my clients are primarily financial services. That means that the security requirements are extremely high. So basically everything that we have cannot use any internet, right? So we can use the internet to download the AI and download the agent, but we cannot send the code, the data to the internet. So if we use private AI, we basically solve all of it. There is no cross-border, there is no data protection problems, there is no code leakage and so on, right? It must be very cheap because those things often start with a POC, right? POC cannot be expensive because nobody would start it, right? So it must be very cheap. So we have zero license cost, zero token cost, and so on, yeah? And of course, now everybody is afraid of GenAI, so there must be human approval, meaning human is always in the loop. Nothing changes without human approving it. So today I would like to just show you 6 agents, input, output, benefits, and how they work. We have more, but just this 6 should be a good sample to, tell you what are the use cases that we can tackle using agents. So the first one that we have is Code AI. It has been designed to solve problems of legacy software. Legacy software has huge amount of problems, but just to focus on something, the top 2 are very low test coverage that has this ugly symptom that developers make changes. Everything is green because there are no tests, right? They deliver the change to production. Stuff breaks in production after a couple of days. They have a couple of days to fix, plus some data corruption and so on. Plus, of course, they need to roll it back, meaning they have the original problem, right? So low test coverage can be really a big pain for developers. Second problem is spaghetti code, right? So recent studies say that developers spend 10 times more time on reading than writing, right? So whatever we would optimize in the reading part, this would be multiplied 10 times, right? And developers in legacy world, they often work 4 or 5 days and then they change just one if. But then they have another problem, the one that I already mentioned, that they make a change and they ship it to production with no tests. What will happen? Yeah, plug and pray. So Code AI solves exactly those 2 problems. The way it works, it gets an input project, Git URL or SVN or whatever, the source control. And for every class in the input project, it has a separate dialog with GenAI in order to get a unit test, right? And of course, answers from GenAI are often wrong, but the way they are wrong is very easy to assess technically. Agents have this capability of running tools, right? So once the agent gets code from large language model, it builds it, right? So obviously the test must compile. Once they compile, we can run them. So of course, then we run it and it fails or not. If it fails, we feed it back to the agent, say, hey, you gave me something that fails, an assertion here, right? Of course, even if it doesn't fail and it compiles, still it may have a number of problems, but basically you can get rid of all of them automatically runtime, while running together coverage for quantity and mutation for quality, right? Plus sonar for code quality. So if you have all those quality gates, it's very difficult to come up with a test that passes all the quality gates and is still wrong. Once we have tests, we get confidence that we can change the spaghetti code, right? So the improvements of spaghetti code, they work on the similar basis. In general, for every class, agent is running another tool, sonar or things like this, check style, and they get you metrics, right? So, for example, you have information that the method is too long, right? So basically, agent feeds this information into GenAI and asks it to split it. And GenAI is very good in splitting methods into smaller methods. It gives them meaningful names. And we also get some additional benefits like just-in-time compiler in Java kicks in when the methods are short. And all of it ends with pull requests, right? So that's the place where human is in the loop. For tests, we get one pull request, and for the code improvements, we get another pull request. And they are pre-built, pre-checked. So there is guaranteed that if you get an improvement pull request, Sonar gives you a higher score than previously, right? Because otherwise, the change would not belong to the pull request. So people still are approving everything, right? But they don't have to worry that they get something that doesn't compile or doesn't work or doesn't pass or anything like that. That's all guaranteed. Okay, so another problem of legacy software, but also actually basically all the projects, is documentation, right? You know, the new joiner joins to the team and asks, where is the documentation? And people start laughing, right? And it's not so funny for this person, I guess. And then somebody says, yeah, the code is the documentation. Yeah, perfect, right? But this new joiner may be a perfect business analyst, which is great in the domain, but has no idea what is linked list or hash map, right? So code being the documentation has these two problems, that it's technical, right? And it's huge, right? Nobody wants to read it all. So Document AI solves exactly this problem. For every file with the sources, you get the file with documentation, together with summaries per package, per module, per namespace, whatever the unit is. And the beauty here is that if the large language model, and usually they are understanding around 50 programming languages, for free, this tool understands 50 programming languages. Plus, of course, the output of the documentation is in whatever language you prefer. For example, we have a client in Brazil where in the teams, not everybody speaks fluent English. And the biggest value for this client was to generate everything in Portuguese. Not the summary, but just the Portuguese language of documentation. So here, in one day, you get full and up-to-date documentation with summaries, and of course, in whatever language you want. Okay, let me now jump to more modern systems. When I say modern systems, I mean like, you know, microservices, running on hundreds of computers. Each computer is running hundreds, maybe even processes. Each process has a lot of files with logs, right? So nobody knows what's going on. Right? Nobody can read it, nobody can check it. Basically, the way developers are using logs is that when there is outage, they go to the logs and look for errors, right? And then they start analyzing. But usually they have a couple of vice presidents calling when they are going to fix it, and this is basically too late, right? So logs contain data, they don't contain information, right? And we want information, such as, for example, let's say your system is processing messages in 100 milliseconds, and then 2 weeks later is 400. You are not at the outage yet. That would happen, let's say, at 800 milliseconds per second. But there is a degradation of performance, and you could spot it. But of course, none of the developers will go to logs and look for that, right? Because it's not readable for humans. And this is one of the use cases here, where, of course, you can also look for security problems and anything. Basically, what what it is a generic mechanism that wires up your logging infrastructure like Splunk, OpenSearch, whatever you have, with large language models hosted privately, so nothing goes out, right? And the initial prompts with those cases of performance or security, basically they are just inspiration because you will have different questions. Right, so you can put your own prompt. It doesn't require releasing of the software. It's externalized. So you just, ask the logs whatever you want. Of course, somebody could argue that, I could set up some monitoring system, right, and it will detect the degradation of performance. Yeah, but you would need to target this particular metrics, and you would set up a lot of processes. Here you can just ask what you want. Okay, Translate AI. So when GenAI was introduced, everybody was thinking about all the translations, right? Because GenAI is the best if you want to have text as input and text as output, right? And for things like COBOL to Java, everybody was thinking like, now how is GenAI coming to the picture, right? So the first thought of people is usually to have a direct translation, right? So I put in COBOL and I ask, give me Java that does the same thing. The problem here is that the Java generated from this would be looking just like COBOL, right? So that means that it will not benefit from being Java, makes little sense, right? So what is usually making more sense is indirect translation. And here is the kind of multi-agent approach where Translate AI agent calls document AI agent, gets the documentation of what the piece of code is doing, and augments it into a prompt with persona pattern, whatever prompt engineering techniques, to generate completely new code which has a chance to drop the dependency on the source technology. Here, of course, we are well aware that with COBOL to Java and things like that, they are extremely difficult. And it is all about data gravity and dependencies, and sometimes you don't have sources of those dependencies. And this will not probably give you something in one day that works, but can speed up the development of the translation by weeks. Okay, TDD. So I think everybody is familiar with TDD, right? So TDD is something like healthy food. So everybody knows that this is good and we should be doing this, right? And so on, but like nobody actually eats this healthy food, everybody go for junk food, right? So developers are aware that if they follow TDD, the code will be very beautiful because it's created from the way it's used, right? It will be minimal because we stop developing when we have the test green, right? And of course it will be tested because we already have the test. Of course for the happy path, but still. So TDD is a great technique. My guess is that developers don't follow this because they don't have the habit, and the habit takes time to create. But in case of agent, it's so much easier because we can just force it. So we created this TDD agent, which as input takes the user story, and it takes a project in which the user story should be implemented, right? And it follows TDD, so it creates the test, right? Iterates as long as the test is compiling, so creates a corresponding code, right? Then when the test is failing, it iterates on the code as long as the test is passing, and then could call Code AI or any other stuff to, work on edge cases, because by default, TDD gives us the happy path test, but we need also edge cases, so it needs to add it on top. And as well as previous ones, it ends with a pull request. So as again, human is always in the loop, right? Nothing happens before, without our approval. Okay, user story agent. Yes, so user story consumes BRD, so business requirement documents. Like 70 pages, PDFs, full of business jargon, something that when developers get, they usually just print it out, because when they say I printed, they don't have to read it today, because I already did something today, I printed out, right? So here, Developers hate it really because it's not written in their language. It doesn't say what should be done. Yeah, this is something that we need to investigate because it describes the result of the change, how it would look like when it's implemented. Usually it's created by managers and business analysts, and developers have a huge problem because they start with a user story. They don't start with BRD. So what are the user stories in this BRD? Yeah, you need to somehow find them out, right? And how many? If you find 8, is it enough? Do you have everything? So this is exactly what user story agent is doing. It detects user stories, lists them. It can find even 20. Then it has references to the original where the user story comes from, and it gives you additional benefits. It also tries to find contradictory statements in the BRD. Often the BRDs are so huge and created by people from different departments that are not aware of each other that they may even contradict themselves. And here it would say, let's say, a statement on line 200 is in a contradiction with a statement on line 700, right? So it gives you additional verifications, plus it can find things that are out of scope but are not mentioned as such. So this gives you as an output user story, right? And just maybe let me jump to some analogies. Future will show if they are correct. This industrial revolution in 19th century changed everything because it introduced this assembly line, right? So one place in assembly is producing something that the second place is consuming, right? And it goes forward. And once they invented those factories, everything kicked off. And now what we may be witnessing right now, it's probably very early days, but we may be witnessing the new assembly of agents, where one agent creates something, right? The second agent picks it up and continues. And here, if we just take one example of the user story agent, which takes BRD and outputs user stories, and the TDD agent, which consumes user stories and outputs the pull request with the new feature code, you can see that we can wire them up together, right? And I would always say that because it always can go wrong, right? And we put more and more quality gates everywhere, and it gets better all the time. But still, there is always space for things are going wrong. So I would say it would be good to have human after each one of the steps that would verify the output this is what we want to go. But there is always a temptation just to make it all automatic and connect and just see what's the end result. So I would like to just emphasize how easy that all is, right? So all those agents are created in Java, right? So they basically run everywhere, Linux, Windows, Mac, right? People are often afraid of the cost of AI, right? Token cost, or they usually heard things like how expensive that is to train AI. But here, all of it is using pre-trained models downloaded from internet, which are completely for free, and we don't change any of the parameter values. So it doesn't require from us any machine learning or data scientists or anything like that, right? If we talk about the cost, I have a decent server for like $200 something per month with GPU, 16 gigs of VRAM, and this is less than $2 per hour, right, to run. And it's okay for all the cases I have described today, right? So it's really low cost. And of course, it doesn't require any of the cloud dependencies. You can run it on any of the clouds, but it's not like it works only on AWS and so on. Often AI solutions have this kind of vendor lock. So it's not the main topic of this presentation, but just a couple of words of the, enterprise transition. I think now all the companies in the world, they are adapting to Gen AI, and everybody is at some stage, right? And of course, if you are at the beginning of the stage, I think Capgemini would be the great partner to help you kick it off. And even if you are already in the journey, that's also great to share experience and confirm direction. My comment on all that is that if you adopt Gen AI, the most important and critical part is the border between human and AI. So in the agent I have described today, this border is pull request, right? So it's very well defined, right? It's defined in the existing terms, right? We haven't invented anything new. It's pull request. Everybody knows it, right? And it's clean and it's in one place, right? So if you have this kind of definition of the border, you can keep things under control, right? So that's very important. Okay, so let me just finish with some statistics. So 82% of organizations that are planning to integrate agents, that's from Capgemini Research Institute, but this is from 2024. But if you think about what happened in 2025 with all the hype, it's now close to 100, but I guess nobody would like to be in the remaining 18 now. So that seems to be the future, if we like it or not. And I would like to talk with all you guys and just let's connect. And I think now we can spend some time on Q&A if you have any. Thank you. Any questions? Anybody?
Let's say we've done some refactoring with code AI,
yeah,
and then pull request is created. What happens if human has some comments on that pull request?
Yeah, that's kind of pull request is not that interactive, right? Basically, what people usually just do in this case, they copy the part of the pull request they like, and they ignore the rest, and they create their own pull request. Because pull requests are not interactive, right? They are not meant to be a subject of change.
Okay, thanks.
Thank you.
How about your experience in case of efficiency, in case of this refactoring stuff? Because today at the first presentation at 10:40, there was a presentation about productivity trap when the guy from the company called CodeScene developed the app which was focused just on the refactoring. And in case of his experience, he said that refactoring using LLM, which were fine-tuned, right now are good enough to refactor at maximum one script, not the multiple files, not the repositories, not the directories.
Yes. Mm-hmm.
And he suggested that 200 lines of code is the maximum what should be right now be done. And the stuff he recommended is just, maybe not just, but he suggested that mainly reducing cleaning the code, reducing the functions, the lower spaces.
Mm-hmm.
He set some boundaries.
Yes, I've seen that. Yes, that's also my experience, right? So in general, if you think how this tool works, right, it runs the build. So your refactorings cannot change tests. Right? So basically you can call them a local refactoring. Basically it goes to splitting method into smaller methods, things like this. It doesn't change the class diagram. It doesn't change your public interface, right? Because you would need to do a non-local change for that, right? So it only gets a file. You have 200 files with Java, right? It changes just one file. So it's only local, right? We'll split public into privates or private into privates. Yeah.
Okay. Hi, thank you for presentation. I've got a question regarding the model itself, because I have seen that you're running on VMs with the
Yes.
core GPU. It's very limited as far as I know in terms of RAM and any suggestions?
Yes, I have one.
What type of the model and
Yes, it's a very good question. So at the beginning, we started with Ollama because it was so easy, but Ollama is primarily a desktop tool, right? So we tried to put it into the backend world behind Nginx reverse proxy for API keys management, but it didn't survive multiple access, right? So we have replaced it with VLLM that is using virtual memory and is much more robust. There are other problems with VLLM. It doesn't support all the quantization algorithms and so on, but it's much more robust than Ollama, and it will, get the most of your 18 or 6 gigs, 8 of RAM, whatever you have. And the model itself, now we are using, basically we are limited to what our clients want, right? So clients don't want to have Chinese models, right? They are afraid of Llama because it has GDPR issues. So they go with Microsoft, Google, and with Mistral, for example, right? So from Google, there is Gemma Free, right? And of course, from Microsoft, there is Pi for reasoning, the recent models, but also like just a few days ago, there was Devstral from the Mistral family has been introduced, right? So we switch to new LLMs every 2-3 weeks, right? Just maybe one funny thing is that Gemma 2 for unit tests provides great hallucinations, and I wouldn't use it. So it gives you calculator tests when you have no calculator in your code. That kind of hallucination, right? So I wouldn't use Gemma 2. I would go for more Gemma free and Pi for reasoning.
Okay, thank you very much.
One more question.
Yes.
So how do you exactly use LLM for log AI? Because I didn't understood like where to put it there.
Yes, so you have the agent, which is written in Java, and it connects to Splunk, to your logs. And the agent itself, it's connected using the LangChain4j to, your Ollama or VLLM or anything like this, right? And agent contains some number of prompts, right, which are kind of just your inspirational prompts because you probably are looking for something more specific to your case, and then you can just put more prompts that you have, and it's basically streaming logs into the LLM, asking for whatever you want in the prompt. Okay. It's a generic mechanism.
Thanks.
I think there's a question there.
Hi.
Hi.
So I have a question because on the market we already have a lot of the tools to support the code development.
Yes.
For example, the CodeRabbit for pull request, CI/CD support, etc. Do you use them or you have your own designed by Capgemini tools?
No, we don't use this one. It's very low level, right? It's a Java application that calls directly large language model, and it's running runtime Maven, Gradle, or custom builds, whatever, how the application is built, right? So it's all very, very low level, but we have full control. Now we will be probably switching to A2A or MCP.
Hi, Maciej here. It was really nice comparison of those agentic workflows to assembly line, but on the assembly lines, there is always a quality control. So if one item is produced, we need to make sure that...
Yes.
Yeah. So how do you take care of controlling the quality of each step in your agentic workflow inside your tool?
It's a very good question, and that's the biggest problem with GenAI, yeah? It gives you something in a minute, but it's usually not the same as you want. And the delta between what you want and what you get may take you weeks, right? So if it's code, then it's easier because you can compile it, run it, and be extremely restrictive, sonar, check style, for test, mutation testing, coverage. If you put all of them together, plus you inject something like it cannot connect to the network, it must be fast. We measure the time, how long the tests are running. We accept only below 100 milliseconds and so. So you can be, if you have those 25 quality gates, it's difficult even for a smart developer to work around them, yeah? But for example, if you talk about document AI, where the output is just documentation, I don't have an automated way to measure that. So my problem is that for integration tests, AI is not deterministic, right? So you need to have some benchmark to be deterministic. So for code, I have it, but for documentation, I don't. I don't know how automatically assess documentation, right? And it's, I guess just human needs to check it and say if it makes sense, but nobody will read all that.
And I think that this is the real problem here, because if the requirements are just bad understood by those LLMs, then the code generated, okay, will be working, the test will be passing, but it will be doing something that we didn't intend it.
Yeah, that's why I would say I wouldn't go for the automated agent-to-agent flow, because it will be accumulation of errors. But if you just have human after each one of them, and if you don't like it, you change it to repeat, then it's probably better. Yeah.
So for now, human in the loop, yeah? Thank you.
Yes, thank you.
Hello.
Hello.
Thank you for the presentation. And going back to the log AI part, as you said, it can be just Java agent that is connected to the Splunk. But how do you leverage the outcome of the data? Meaning you're creating some automated dashboard with recommendations, maybe alerts in Splunk, maybe...
Yes, we are preparing this, but our problem is that we are all backend guys. So all this stuff is just command line, right? But yeah, we are preparing, or we will generate this, some dashboards to have some nice UIs.
Okay, thank you.
Thank you. Okay, thank you very much.